inductance of coil X will be L1 and the self-inductance of coil Y will be L2. So we have L1 is equal to N1 phi 1 by I1, because we saw that L is equal to N phi by I. So for coil X, we can say that L1 is equal to N1 phi 1 by I1. So phi by I is equal to N by S, because flux phi is equal to Ni by S, that we saw in our last lecture. So that we can conclude that N phi by I is equal to N square by S. So here for coil X, L1 is equal to N1 phi 1 by I1, and putting the value of phi 1 by I1, we can have L1 is equal to N1 square by S. Similarly, for coil Y, we can have L2 is equal to N2 square by S, where N2 is the number of turns of the secondary side and S is known as the reluctance. Friend, we discussed reluctance in last lecture. What is reluctance? So reluctance opposes the production of magnetic flux. Same in electric field. In electric field we saw resistance, which opposes the flow of current. So in magnetic field, S is known as reluctance, which opposes the production of magnetic flux. Suppose the flux in coil X is phi 1 Weber. So the total phi 1 Weber will not be linked with another winding, but let a part of this flux, it means K1 phi 1, link with coil Y. Then the flux linkage of coil Y becomes N2 into K1 into phi 1, where N2 are the number of turns of the secondary coil or Y coil. So the mutual inductance between two coils will become N is equal to N2 into K1 phi 1 by I1, where N2 are the number of turns of coil Y. K1 phi 1 is a part of flux which is linking with coil Y, and I1 is the current which is flowing in coil X. But we have a relation phi 1 is equal to N1 by I by S, so that we have M is equal to K1 into N1 N2 by S. This is the flux of X which is linking with coil Y. Now similarly, coil Y carries a current of I2 amperes. So the flux produced in the coil Y will also link with coil X. So here we can have phi 2 is equal to N2 I2 by S. So the mutual inductance of the between two coils will be M is equal to N1 into K2 phi 2 by I2. And after substituting the value of phi 2, which is N2 I2 by S, we can finally get M is equal to K2 N1 N2 by S. So this mutual inductance is for coil Y, and we saw the mutual inductance for coil X was M is equal to K1 N2 N1 by S. Multiplying both the equations, we get M square is equal to K1 K2 N1 square into N2 square by S square. After that we can have K1 K2 into N1 square by S into N2 square by S. So what is N1 square by S? N1 square by S is simply the self inductance of coil X, which is L1, and N2 square by S is the self inductance of coil Y, which is L2. So we can have M square is equal to K1 into K2 into L1 into L2, and after that we can find M is equal to under root K1 K2 into under root L1 L2, and then we can conclude that K is equal to M by under root L1 into L2. So here the K is known as the coefficient of coupling, and the value of K is under root K1 into K2. So finally the K is equal to M by under root L1 into L2. Here we will see the alternate methods to find the mutual inductance M. Friend, remember M is equal to the flux linkage of the second coil by the current in the first coil. So the flux linkage of the second coil is N2 into phi 1, It means that phi 1 is the flux of the primary side and N2 are the turns, number of turns of the secondary coil. And the current in the first coil is I1. So finally we can say that M is equal to N2 into phi 1 by I1. So the mutual inductance between two coils is said to be 1 Henry if one coil carries a current of 1 ampere and produces a flux of 1 Weber per turn in the other coil. We know that M is equal to N2 into phi 1 by I1. Putting the value phi 1 by I1, which is N1 by S1, we get M is equal to N2 into N1 by S1. And then we get M is equal to N1 N2 by L by mu 0 into mu R into A, where L by mu 0 mu R into A is the value of the reluctance S. So we get the value of mutual inductance M is equal to mu 0 mu R N1 into N2 into A by L, where mu 0 is the permeability of air, mu R is the relative permeability, N1 are the number of turns of coil X, N2 are the number of turns of coil Y, A is the area of the circuit, and L is the total length. Friends, electromagnetic induction is there in transformers. So we can see what transformer do and how it uses the electromagnetic induction. In transformer, we have three things. The first thing is a magnetic core. This is magnetic core. After that we have a primary winding, which is connected with AC supply, and on the other side we have secondary winding, which is connected with load. So this is, we can say, a basic transformer. Here in transformer, the primary current I1 flows through the first coil, and then the flux phi 1 will be there in the core. The flux phi 1 will travel through the core and will be linked with another coil, and EMF will be induced in the another coil. Here we can see number of turns at primary side are less, and number of turns at secondary side are more. So if the number of turns at the primary side are less and the number of turns at the secondary side are more, then this transformer will be known as step up transformer. And if number of turns at primary side are more, here we can see, if we take more number of turns and number of turns at the secondary side are less, then that transformer is known as step down transformer. So this is basically electromagnetic induction is used in transformers and in alternators. Here we have a picture of transformer in which the red windings are the primary windings and it is connected with a core, and the secondary winding is given as blue windings, which is connected with the secondary side, and the transformer works on electromagnetic induction. Now we can have example. Here the example says that a flux of 0.7 milliweber is produced by a coil having 1100 turns and the current is given as 2 ampere. So we have to find three things. First thing is self inductance of the coil, which is L. The second thing we have to find is EMF induced in the coil when a current of 4 ampere is switched off, assuming the current to fall to 0 in 2 milliseconds. And the third thing we have to find is the mutual inductance, and the second coil is given as 700 turns. Now here number of turns at primary side N1 are given as 1100. The current on the primary side is 2 ampere and the flux is 0.7 into 10 raised to minus 3 Weber. The number of turns at secondary side are 700. So here first we will calculate the self inductance of coil 1. The self inductance of any coil is given by L is equal to N phi by I. N are the number of turns, phi is the flux and I is the current. So here for coil 1 we will have L1 is equal to N1 phi 1 by I1. N1 is given as 1100, phi 1 is given as 0.7 milliweber. It means 0.7 into 10 raised to minus 3 Weber. And the current is given as 2 ampere. So putting the value of the current, the number of turns and the flux, we finally get L1 is equal to 0.385 Henry. So the first problem is solved. The self inductance of coil 1 is found. After that we have to find the EMF induced in coil 1. So the formula for the induced EMF in coil 1 will be E1 is equal to L1 di by dt, where L1 is the self inductance of coil 1. So here putting the value of self inductance of coil 1 as 0.385, the change in current is 4 ampere with respect to the time. So we can finally get the value of induced EMF in coil 1 as 770 volt. So the second thing is also found. Now we have to find the mutual inductance between two coils. So the mutual inductance between two coils is given as M is equal to N2 phi 1 by I1. Here we can use this formula because the flux of first coil is given as phi 1, the current of first coil is given as I1, and the number of turns of the secondary side are given. So we can use this formula M is equal to N2 phi 1 by I1, where N2 phi 1 is the flux which is linking with the secondary coil and I1 is the current at the primary coil. And after that we put the value of phi 1 by I1, which is L1 by N1. So we can get M is equal to 700 into the self inductance of first coil is 0.385 by the number of turns 1100. So we concluded the value of mutual inductance M is equal to 0.245 Henry. So here the example is done. We have find three things. Firstly, the self inductance of the first coil, which is 0.385, and the formula was L1 is equal to N1 phi 1 by I1. The second thing is also found, which is the EMF induced in coil 1, which is E1 is equal to 770 volt. And the third thing, which is mutual inductance, is also found, which is M is equal to 0.245 Henry. Now another example on electromagnetic induction. Here we have two coils. The first coil is having 30 number of turns and the second coil is having 600 turns. They are wound side by side on a closed iron circuit and the cross sectional area of the iron circuit is 100 centimeter square. The mean length is given as 100 centimeter. So we have to find the mutual inductance between the coils. After that we have to find the self inductance of each coil, which is L1 and L2. And then we have to find the EMF induced in the second coil when the current in the first coil changes from 0 to 10 milliampere. It means the change in current is given as 10 milliampere in 0.01 second. The time dt is given as 0.01 second. And the relative permeability of iron is given as 2000. Here number of turns, N1 are the number of turns of primary side, which is 30, N2 are the number of turns at the secondary side, which is 600. The area is given as 100 centimeter square. So we can have the area as 100 into 10 raised to minus 4 meter square. The length is given as 100 meter. So we can have a length 100 into 10 raised to minus 2 meter. Firstly, we will find the reluctance of the magnetic circuit. So the formula of reluctance of magnetic circuit is L by mu 0 mu r into A, where L is 100 into 10 raised to minus 2 meter, mu 0 4 pi into 10 raised to minus 7, mu r, which is relative permeability, which is given as 2000, and the area of iron is given as 100 into 10 raised to minus 4 meter square. So we can calculate the reluctance as is equal to 39809. Now we have to calculate the self inductance of coil 1. So the self inductance of coil 1 is given as L1 is equal to N1 square by S. We have number of turns N1 as 30 and S we found. So here by putting the value N1 square, it means 30 square by the value of S, which is 39809, we get the self inductance of first coil as 0.0226 Henry. Now we have to find the self inductance of second coil. So similarly, the formula for the self inductance of second coil will be L2 is equal to N2 square by S, where N2 are the number of